The second session of the chapter Proteins explains essential and non-essential amino acids with example, then ionic properties and reactions of amino acids. Coming to essential amino acid, what do you mean by essential and non-essential amino acids? In the previous session, we have seen that the living organism, the proteins are made up of 20 sets of amino acids. Among these 20 amino acids, certain amino acids are essential amino acid and some are non-essential amino acids. So we'll see what is this essential and non-essential amino acids in this session. Amino acid which cannot be synthesized in the body and so it should be supplied through the diet are called essential amino acids. It means these amino acids are not synthesized or produced in the body. So it has to be, but it is essential for the growth of the living organism, human body. So it has to be supplied through the diet. For this category, we have 10 amino acids which can be given as an example for essential amino acid. They are valine, leucine, isoleucine, phenylalanine, tryptophan, lysine, arginine, histidine, methionine, as well as threonine. These 10 amino acids are essential amino acids which should be supplied through the diet as it is not produced in the body. Coming to non-essential amino acid, the just reverse of that of essential amino acids. These are the amino acid which are produced in the body. So we need not supply these amino acid through the diet because sufficient amino acid, these amino acid in sufficient quantity are produced in the body. In this category, we have seven amino acid: alanine, glycine, proline, isoleucine, leucine, valine, methionine, etc. can be given as an example for non-essential amino acids. Then coming to ionization of amino acid. How we get the ionized structure of amino acid? We know that in amino acid we have two functional groups which are amino group and carboxyl group. So they are crystalline solid with a very high melting point. They are solid. Amino acids are solid with a very high melting point. They are soluble in water. Then these properties indicate that these type, that is crystalline nature and solubility in water, indicate that they exist as charged molecule. They exist as an ionic compound because these are the properties of an ionic compound. Ionic salt, we can say it is a property of salt where the same compound has both positive ion and negative ion. So such a structure should be possible for amino acid which explain this property. These properties indicate that they exist as charged molecules called zwitterion with positive and negative charge. But the net charge of each amino acid will be 0. One positive charge will be neutralized by the negative charge of the molecule of another group in the same molecule. So the overall charge of amino acid will be 0 or it will be neutral. Because amino acids have both basic and acidic group, they are amphoteric in nature. It has both acidic, that is basic means amino group has basic property and carboxyl group has acidic property. So such a compound which possesses both basic and acidic properties are termed as amphoteric molecule. The amino acid can be given as an example for amphoteric molecule. Here you can see the ionization of amino acid into zwitterion. Look at the structure here. Carboxyl group, which is acidic. Acidity means it has a property of losing the proton. This carboxyl group can give off its proton. So when H plus is lost from this carboxyl group will become COO minus. And the produced H plus will be accepted by the lone pair of electron on nitrogen. Then NH2 will combine with an H plus to form NH3 plus. So here we have lost one proton to form carboxylate anion, and here we have regained one proton, anilinium, that is NH3 plus ion. So this is the structure of a Zwitter ion. Then at low pH, the carboxylate anion, this is structure of Zwitter ion. So this one at low pH, what will happen? Low pH means the solution is acidic. Acids are having low pH. pH 1 to 6.9 are acids. Then 7.1 to 14 are bases. At low pH, the carboxylate group accept one proton and become carboxylic acid, COOH. It will become COOH. So first there is the formation of from the anion, Zwitter ion. From Zwitter ion, what is happening? Zwitter ion in low pH, H plus is combining with carboxylate anion to form carboxylic acid, which is charged. Carboxylic acid, which is uncharged. The overall charge of the molecule is now this carboxyl group, overall carboxyl group is now having no charge. This negative charge is neutralized by the addition of the proton. Now the remaining charge is positive charge. The molecule will be positive charge. At the same time, at high pH, amino group NH3 plus, what will happen at high pH? NH3 plus will combine, it will be losing one H plus to form NH2. It will be losing one H plus to form NH2, and that time this carboxylate anion charge will be there, or the molecule will be negative. So only at one particular pH the amino acid remain as neutral. At low pH the charge of the molecule is positive. At high pH the charge of the molecule is negative. So this particular pH where there is no charge, the amino acid remain as Zwitter ion or neutral structure, is termed as isoelectric pH. Isoelectric pH of an amino acid is that pH at which its molecules are in the form of Zwitter ion with no net charge. At this pH, the solubility of amino acid is minimal and it does not migrate when placed in an electric field. So at this pH, in this particular pH, that is isoelectric pH, even if we keep it is in an electric field, it will not migrate either towards cathode or towards anodes. Coming to the reactions or chemical properties of amino acids, we know that it possesses two functional groups, amino group as well as carboxyl group. So the chemical properties of amino acid will show the properties, the reactions of carboxyl group as well as reactions of amino group. So in certain reaction, amino group will react. In certain reaction, carboxyl group will react. Let us see what will happen when amino acid is reacted with alcohol. With alcohol, amino acid react with alcohol to form esters, because we know alcohols are basic in nature. Amino group is also basic in nature, so there will not be any reaction with the amino group, but carboxyl group will be acidic in nature. So carboxyl group will combine with this alcohol with the elimination of one water molecule. We know the reaction between a carboxylic acid and an alcohol will give ester. Same reaction is taking place here. The carboxyl group of amino acid is combining with this amino alcohol to form ester. We can take an example also. Alanine, we can take one CH3. If R is replaced by CH3, the amino acid will become alanine. So alanine combining with methanol, we can say CH3, CHNH2, COO, CH3. The H should not be there. It should be COOR. Reaction with nitrous acid. HNO2 is termed as nitrous acid. When amino acids are treated with nitrous acid, hydroxy acids are obtained or oxo acids are obtained. So RCHNH2COOH plus HNO2 will give you RCHOH. Here the reactive group is amino group. Carboxyl group is not reacting because this is an acid and carboxyl group is again an acid. So NH2 is a base. So NH2 will combine with HNO2 to form OH functional group, that is hydroxyl group. So RCHOH, hydroxy carboxylic acid, will be the product with the elimination of nitrogen gas. This is what happening when amino acid is treated with nitrous acid. Coming to an important reaction, that is reaction with ninhydrin. Ninhydrin reacts with all alpha amino acid to give a purple colored compound whose absorbance can be measured at 570 nanometer. This is ninhydrin. So ninhydrin can be, it will be combining with all alpha amino acids to give a purple colored compound. This compound is the having the color purple color, but only in the case of proline. Instead of this amino acid, if it is proline, this compound will have the color yellow. All other amino acids will have a color purple, which can be measured at 570 nanometer. But amino acid proline, if it is getting substituted with ninhydrin, we get the complex, which is the combination product, which has the color yellow color and which can be, whose absorbance can be measured at 440 nanometer. This, so ninhydrin can be used as for both quantitative as well as qualitative analysis of amino acid. We can use it as for detection whether a given sample contain an amino acid or not. That can be done by combining the given amino acid with ninhydrin. Now, formation of peptide bond. How two amino acids are joined together. To form a protein, many amino acids should join together. Then only the polymer will be formed. So, how a peptide bond, how two amino acids are joined. So, two amino acids are joined together through peptide bond or peptide linkage. It is an amide linkage. So, peptide bond are special amide linkages between the alpha carboxyl group of one amino acid and the alpha amino group of the next amino acid. So, when two amino acids are combining, we should write in such a way that the carboxyl group of the first amino acid is facing the amino group of the second amino acid. So, what will happen? Both carboxyl group and amino group will combine and there will be elimination of water molecule that will be lost, and what is remaining here, CO is remaining and here NH is remaining. Through this bond, the two amino acids are connected. They are linked. So this particular linkage, that is CONH linkage, is termed as peptide group. Peptide group or peptide linkage is the bond which is joining two amino acids. How to name this peptide? If two amino acids are joined together through peptide bond, how can we name them? They are named starting with the amino acid residue that has free alpha amino group. For the first amino group, NH2 terminal will be free. For the second amino group, carboxyl terminal will be free. So let us take glycine and alanine. So this is glycine and this is alanine. And here the carboxyl group of glycine is combining with the amino group of alanine to form a peptide bond. So the dimer, that is when two amino glycine and alanine are combined, the combined structure will look like this: NH2CH2CONHCHCH3 COOH. So first amino acid is glycine, other one is alanine. So we can name this peptide as glycylalanine. Instead of INE of glycine, that is replaced by YL, and the second one is written as such. So first one, INE of the first amino acid glycine, INE is replaced by the term YL. If there are one more amino acid, here also this INE will be replaced by YL, and the third one will be written in full name: glycyl, alanyl, serine, etc. For example, look at the example here: structure and naming of alanyl, glycine, serine. First one is alanine, second one is glycine, third one is serine. So first one whose N terminal is free, alanyl, then glycyl, second one, last one as such as a complete amino acid whose carboxyl terminal is free, that is serine. Alanyl, glycyl, serine is the name of this peptide. This one, there are three amino acids which are joined together by two peptide bonds, and it is an example for a dipeptide. This one, previous one, is an example for a monopeptide because only one peptide bond is there. This is an example for monopeptide. This is dipeptide. Three amino acids when joined together through two peptide bonds, it can be called as a dipeptide. Now peptide, polypeptide and protein. Polymers of less than 25 amino acids are peptides. So till 25 amino acids when joined together, we can just call them as monopeptide, dipeptide, tripeptide, tetrapeptide, etc. etc. Polymers of more than 25 amino acids are termed as polypeptide. If it is crossing 25 to 30, it is termed as polypeptides. Polypeptide with more than 10,000 Dalton molecular weight are called protein. So proteins are polypeptide with more than 10,000 Dalton molecular weight. These proteins, which are functional and exhibit biological activity, they consist of one or more polypeptide chain. So please don't have the impression that only one polypeptide chain is possible for one protein structure. There can be one, it may be one, or it may be more than one polypeptide chain also. Coming to the summary, whatever things what we have seen in this session, we have seen the definition for essential and non-essential amino acids with examples. Then ionic properties, that is ionization of amino acid, Zwitter ion term and isoelectric pH, all these things we have seen. Then coming to the reactions of amino acid with alcohol, nitrous acid and ninhydrin we have seen, and definition or the formation of peptide, polypeptide and proteins also we have seen in this session.